determine where the function is concave up and where it is concave downward. So concavity means second derivative. So let's find the second derivative of this function. So first derivative is simply 3 times 4, 12x squared minus 4. Now second derivative is then 2 times 12, 24x minus 0. Don't have to write. Now we set second derivative 0. That is 24x equals 0. Need to solve for x. 24 times x. So divide by 24. So x equals 0 over 24, which is 0. So x equals 0 is a candidate for inflection point. X coordinate of inflection point. It could be, or it maybe not. We'll see. Now look at this. This is a third degree polynomial. So the domain is all real numbers. So we need to do this sign chart. Negative infinity through infinity, and possible inflection point is at 0. So somewhere 0 is here. Now we need to check these two intervals. We pick a representative, anything here in between negative infinity and 0, maybe negative 1, here is 1, and we plug these representative values into second derivative, that is 24x. So sign of second derivative, plug in negative 1, so 24 times negative 1, that's negative. So second derivative negative means the function is concave downward. Plug x equals 1 in here. 24 times 1, 24, which is positive number. Second derivative positive means the function is concave upward. So the answer is, the function is concave upward on here 0 through infinity. The function is concave downward on negative infinity through 0. At 0, the concavity changes. So we can find the inflection point, which is not asked in the question, but inflection point means where the concavity changes. Point means x coordinate and corresponding y coordinate. X coordinate is 0. Now we plug x equals 0 here in the function, okay? Whenever answering the here, we plug in here. We use second derivative just for the test, but final answer is given from the function. 4 times 0 cube minus 4 times 0, simply 0. So the inflection point is at origin. This is not part of the question here though.